Chapter 16, Semiconductor, Magnetic, and Optical Memory. This chapter will go over those three types of memory. To understand memory, we'll understand the memory concepts. Memory locations have memory addresses. Data are memory contents. 8 bits, known as a byte, is a data bit. This is a logic diagram or chip diagram for an address bus going to an address decoder, which is right here, or 74 LS154, to our other decoders, the 74 374, to our 8-bit data bus. This is what the waveform looks like with our addresses. You have the old address to the new address, corresponding with the data, the old data to the new data. There's a small bit of propagation delay between those two, as well as the write function. So at that point in time with the write, it takes that time to set the write, and with the setup time and the propagation delay TP to create the new data onto the output bus. Static RAMs is random access memory or read-write memory. It's a temporary storage of data like all RAMs are. The user can access data at any location randomly. CD player or hard disk has static RAMs. Static RAM is basically uses flip-flops as basic storage elements, whereas a dynamic RAM uses capacitors as basic storage elements. It needs additional refresh circuitry, and it can be densely packed and a lower cost per bit. The 2147H static MOS RAM has 4096 memory locations. It's a 4K RAM. It's 4 by 1K 1024. Each location can contain 1 bit. 4096 unique addresses. That corresponds to the 2 to the 12th power, and it's got A0 to A5 identifying rows, and A6 through A7 identifying columns. Row and column circuitry pinpoint the memory cell as to which one you want to pick, and so on and so forth. It's got a row select and a column select device. Uses 3 tri-state buffers to allow the output to be read. This is the example with that chip, the 2147, with its read and write cycle. With its chip select function, it takes the new address and the data and puts it through, so it makes it the data valid. And that's exactly how this device works. Another form is the memory expansion, using multiple chips to get more memory capacity. This is shown here with this the same chip, but you have 8 of them instead of 1. This combines the original 4000 to 8 times that. Dynamic RAMs require more circuit support. They're more difficult to use, are high density, minimizing circuit board area. Usually multiple address lines, like on the level of 16 or 32, and a capacitor refresh during refresh cycle. The refresh cycle timing is usually every 2 milliseconds or sooner. This is an example of the dynamic RAM, taking from the address bus into the RAM controller and out to the data bus. Read-only memories, or ROMs, that store data on a permanent basis. They're non-volatile, and EEPROM is erasable, programmable, read-only memory. It stores operating systems, table lookups, and language compilers mostly. The mask ROMs are one-time fee to design a unique mask, very inexpensive after one-time fee. A fusible link PROM or programmable ROM, you can avoid the one-time fee. Every memory cell has a fusible link, burned open to permanently stored data. An EEPROM can change the memory contents, and it can expose an open window to ultraviolet light, slowest erasable time. An EEPROM, an electronically erasable programmable ROM, is non-volatile and erased while still in circuit. Individual bits are erased one at a time. Flash memory, the most recent type of memory that has been brought to the market, is fast access times. It can erase entire blocks quickly, and it's used in digital cameras and PDAs. Floating gate MOSFET is used. Charge time remains on gate for about 10 years, and it has one-time programming. These are the different types of ROMs using semiconductor memory. This is a table of exactly what I had just gone over. Memory expansion and address decoding applications. Address decoding identifies which IC is to be read or written to. And this is an example of the microprocessor, and you have your RAMs here, followed by the address decoder here, which enables. You have an application, a programmable ROM lookup table. You have your binary and your gray code. It basically takes the binary code and outputs the exact same gray code through the ROM. You're just programming it into the chip. Digital LCD thermometer. Another application that one covers several topics from within this text is a digital Celsius thermometer. In this application, a PROM lookup table simplifies the task of converting meaningless digital strings into decimal digits. This is done via the circuit. You have your 8-bit ADC with your thermistor. It takes those values in through an 8-bit digital string, programs it into the address lines with the programmable ROM. It takes the programmable ROM part and outputs to your 8-bit LCD display. So it inputs the thermistor values into the PROM, programs them into the ROM, burns them into the ROM, and then outputs them to the LCDs. Magnetic and optical storage. It is electromechanical in nature, non-volatile. The magnetic form is a north-south or south-north polarity form, and the optical, it pits and lands read by a laser system. It's slower, both are slower and bulkier, but less expensive, and higher storage capacities are available. The magnetic memory, the floppy disk and hard disk, magnetizable mediums. Their rigid plastic jacket, floppy disk, is your standard 1.44 megabytes, and it's removable in type. And your hard drive is not removable, and it varies in size depending on which one you can get. You can get up to about 200 gigabytes nowadays. And there's more information about your hard disk type memory. And you also have removable hard disk, your zip disk, and your Jazz cartridge. These are two other types of storage devices that are out on the market but aren't as commonly used as your CD or your hard drive. CD is not as fast as hard drives. It is removable. They're about 650 megabytes to about 800, and they're aluminum alloy coating. CD, CDR, your readable CDs are very common nowadays with CD burners. It's not too important to know, but most people already know that CDs are used for other storage devices. And you have your read-write CD as well in the same format as an optical memory system. So in summary of your memory systems, a simple 16-byte memory circuit can be constructed from 15 6 optical D flip-flops and a decoder. This circuit would have 16 memory locations selectable by the decoder with 1 byte or 8 bits of data at each location. Static RAM, or random access memory, are also called read-write memory. Typical RAM is the 2114A. It's organized as a 1K by 4. Dynamic RAMs are less expensive per bit and have a much higher density than static RAMs. Their basic storage element is an internal capacitor at each memory cell. An external circuitry is required to refresh the charge on all capacitors every 2 milliseconds or less. And they're generally multiplex their address bus. This means that higher order address bits share the same pins as lower order address bits. And ROM is used to store data on a permanent basis. It is non-volatile, which means that it does not lose its memory contents when power is removed. And you've got your 3 types, your PROM, your EEPROM, and your EEPROM for memory, as well as your flash, your optical and magnetic storage devices